right, here we go. Our objective for today, I can solve and graph one variable inequality. Let's read it together. 1, 2, 3. I can solve and graph one variable inequality. So we're no longer on expressions. We finished expressions. We went into equations, multi-step equations. And now we're starting with inequalities. Fairly similar, but not quite. Okay? So make sure you copy that. And our concept, like I said, our concept's going to change to inequality. So what are inequalities? So on your Frayer model, write that in there. Inequalities. Inequalities, here goes the definition. Instead of writing all that, just write whatever I underline. Here it goes. Inequalities are expressions not equal to each other. Expressions not equal to each other. And just write at the end, one unknown variable. Expressions not equal to each other, one unknown variable. Expressions not equal to each other, one unknown variable. Expressions not equal to each other, one unknown variable. Expressions not equal to each other, one unknown variable. Expressions not equal to each other, one unknown variable. Look at the examples. We have x plus 2. This is an algebraic expression. 25 is a numerical expression. And this is an inequality symbol, which indicates that they're not equal. Are we there so far? Same thing with this one. 12 is greater than y minus 8. This is an algebraic. This is a numeric. And it goes along the same way all the way through. Expressions not equal to one another, and they contain one unknown variable. Look at this. One unknown variable, one unknown variable, one unknown variable, and so on and so forth. Okay? Look at the none examples. X plus 5 minus 25. 12 equals x minus 8. X squared plus 5 is greater than 30. 4x plus 6 less than or equal to negative 2y. So think about it. If these are inequalities, one variable inequalities, why are these not one variable inequality? Think about it. Okay, talk it over with your neighbors. Why are these not one variable inequalities? Go. So once again, the most important thing to remember, have inequality signs, one unknown variable, no exponents greater than one variable on the variable. And that's because we're going to look at these quadratics later on. Okay. So far we're good. Inequalities, one variable inequalities are expressions not equal to each other. They only contain one unknown variable. Okay. Steps. Write these steps down, please. 4 basic steps. Remember these. Simplify, isolate, plot, check. Simplify, isolate, plot, check. Since you already have them, you don't have to write the whole thing. Just write the 4 key words. 4 key words. Okay. What I do need you to write is this next table. Here we go. Oh, before we get to the table, pens down, please. So here goes the introduction again. I went ahead and I remember when we got to equations, I introduced equations using this, right? Scales. And I said, the reason that they're called equations because the scale has to remain balanced. That's why whenever we do to one side, we have to do to the other side in order for it to remain balanced. And I remember I introduced this using beans, and I said if I add 8 pounds of beans to this side, what's going to happen? It drops. So if I was to compare these two numbers, 8 and 0, the original position of this bar is about right there. So therefore, do you see the arrow forming? Yes. So therefore, to compare this using the inequality symbols, 8 is greater than 0. Everybody see that? But as soon as we add weight to the other side, it becomes an equation because it balances out again. Are we there so far? Yes. No. That's why I want you to think in regards to the scale. Don't think about the Pac-Man. Don't think about the alligator. because that's what got you confused now in regards to where is it pointing, right? That's why I want you to think about using the scale. So now check this out. What if I add weight to this side? Which side is heavier? The 11. So therefore, if I was to compare these two, the 8 and the 11, this was originally there, but now it dropped to that position. Do you see the arrow? Yeah, the arrow is pointing that way. Do you guys see it? So therefore, if I was to read this, 8 is less than 11. Are we there so far? So this is what we're going to use for this lesson. So make sure you remember the scale, okay? So that's going to clarify some of you that are thinking like, oh, I get confused with the arrow, which way it goes. So hopefully this will clarify it, okay? So with that said, copy this table down, please. In the back. But on the Q side, copy these symbols. This one. On the Q side, less than, just draw the little arrow that way to the left, and it's called less than. The arrow to the right is called greater than. The arrow to the left, but it has a little bar underneath, that's called less than or equal to. The arrow to the right with a little bar underneath, that's called greater than or equal to. And we've been using this one a lot, not equal to. Is that correct? Yeah, we already been using this one, not equal to. Copy those. All right, so on the back side, copy this table, please. Oh, and also, I already introduced the solution set. Is that correct? Yeah. So check this out. So you're going to make 3 columns. One that says words. Make sure you leave space there. And then one that says algebra. And this one that has a graph. So copy these graphs down. Now check this out. I want to point out these couple of things. When you graph this first one, notice that this one, everybody look up, the point has an open point. You guys see that? Same thing right here. This one is an open point. However, look at this one. This one is closed. You guys see that? Yeah. And this one is closed. So when you're graphing these, make sure it looks like this. And notice here, the red is shaded all the way this way, which it means that it's all these numbers and it continues, which it means this one all the way to the right and it continues, and so on and so forth. Okay, copy that, please. All right, pens down really quick. I'm going to give you some more time to copy, but I want to get started with this first one, okay? Pens down, please. Eyes up here. So check this out. So before this was this. Let me show you that number line before it became that. Do you see this number line? It's in here. You guys see it? Okay. The only thing now, to become like that, you probably did this on your paper. You did, oh, it's, let's see, it's 0, and then you did the dash, and then you circled it. You didn't bubble it in, is that correct? And then you did, like, you shaded all this. And then at the end, you pointed an arrow going that way because that's how it was shaded. Is that correct? Okay. I just want to make sure that I showed you what is happening here. Okay? So here we go. With that said, in order for us to write inequalities or graphing inequalities, pay attention, please. I need a starting point. Okay? Do you see how this number line has a starting point? Or this graph right here. It starts at what? 5. However, it shades all these numbers over here. Does everybody see that? So if you were to ask, or think about it, I'm going to have you think about a number. Everybody look up to the screen. Think of a number that's in this area. Okay? It could be any number, including decimals, long decimals. Long decimals. Think about it, okay? So now, think of a number that's in that shaded area. Will I be able to guess each one of your numbers? No, because I would never know if you're like, oh, Mr. Q, 2.999999999999999999999. Does everybody understand what I'm saying? It could be any number in there. So would I be able to guess? No. So what I'm saying is that this area represents all those numbers. Since we don't know what particular number, we're going to label it what? X. So therefore, I would label that X. Okay. However, it doesn't have a starting point, which is what? 5. Are we there so far? So now check this out. This is how we know how to write the arrow. No longer I want you to start thinking, oh, the alligator and all. No. Let's think about using the scale. Here it goes. I'm going to draw my scale. Pens down, please. I'm not going to draw the whole thing. Just imagine these are the plates of the scale. Does everybody see them? The one on the left? Okay. So where does it start? It starts here with a number 5. Okay, does everybody see that? I'm going to pick one of these numbers to compare it to that. The easiest one I can think of is 0. Okay? So by looking at it, if I was to place these on the scale, which is the heaviest one? 5, or the greatest one. So therefore, if it starts, if this is the bar, this side is going to drop. Is that correct? So therefore, the arrow should point to 0. Does everybody see the arrow pointing to 0? But look at here. Do we have 0 here? No, but what do we know X represents? It represents all these numbers, including, so the arrow is going to point to the X. Everybody see that? Copy that, please. I'm going to do the next one. Now, here we look up. Notice that on this one, on the first one I didn't write the little the bar underneath of it. Why do you think? Look at this. Because this is an open circle. Does everybody see that? So now check this out. So I'm going to start with this one. The starting point is what? -1, and it has all these numbers that represent what? X. So I'm going to write X and -1. You're saying, Mr. Q, hold on, guys. You're probably thinking, Mr. Q, why didn't you write EX on that side? Because I want to make sure that you understand what we're looking at, not just looking at patterns. I want to make sure you understand. So I'm going to write X that represents all of these, and -1, which is the starting point. Are we there so far? So check this out. I'm going to use my scale again. Here are my 2 plates. But now it starts on this side. I'm going to use a -1. And over here, I'm going to compare it to one of these, let's say 3. So look at those 2. Which is the greatest one? 3. So the original bar is there. That means this side is going to drop because it's the greatest one. And now the arrow is pointing where? To the -1. So let's look at the 2 things that we wrote. Do we have a -1 here? So the arrow should be pointing to the -1. So this is X is greater than -1. Everybody see what I did right there? Okay, copy that, please. All right, so check this out. Let's do this one together. Everybody look up. Let's do this one together. Oh, and by the way, notice that this was an open circle. That's why I didn't write the equal sign or the bar underneath. Does everybody see that? Okay, so here we have what? X, and what is our starting point? 1/2. Okay, so let's do this one together. I'm going to erase my scale, and I'm going to redraw a blank one. Here it is, so I can compare those 2 numbers. So here we have what? No. Any number, I'm going to start with the starting point. The starting point is on this side, so I'm going to write the 1/2 here, because it's on this side. And which number do you want to use here? 0? Okay, I'm going to use 0. Okay. Looking at those 2, which one is greater? 1/2. So if it starts here and then it drops because this is heavier, the arrow is going to point to what? To 0, which is represented by X. So therefore, this one points that. However, is this a solid point? Yes, so that's why we need to draw the little equal sign. Do this last one. Write your inequality by yourself. We already got the first, the second, the third. See if you can write this last one. Go. Okay, so x and 0 greater than with an equal sign underneath. Okay, why? Because of the solid points. Question. All right, so now let's see what it means in words. All these numbers, what do we know that they are? They're real numbers, aren't they? Because they're on the real number line. So this is read like this. All real numbers, except what? All these over here, is that correct? So that means all real numbers less than 5. Check this out. This is how it reads. All real numbers less than 5. So this one should read all real numbers, what? Not less than, greater than -1. Look at this one. All real numbers less than or equal to half. Yes. And this last one. All real numbers, what? Greater than or equal to 0. Kind of, sort of? Okay. So here we go. Example number 1. Copy this down, please. Example 1. Here we go. Copy this down, please. Example 1. It says, graph each inequality. Okay? So now this is a little different because now they're not giving us a graph. Now we're actually going to graph this. All right? So check this out. So first things first. We go through our steps. Our steps are simplify, isolate, plot, check. Can I simplify both sides? It's already simplified. Can I isolate the variable? It's already by itself. That means we need to plot our solution. So here it goes. I draw my number line. There it is. Here's 0, 1, 2. Where's 3/4? About right there. Is that correct? Okay. Look at the symbol. Everybody look up. Look at the inequality symbol. Does it have the equal sign? Yes, that means it's going to be a solid point. A solid point. Why? Because it has a little bar underneath. Does everybody see it? So let's read this. This says m is greater than 3/4. What numbers are greater than 3? Yeah, or equal. That's why I already included this point. But what numbers are greater than 3/4? 1, 2, 3. Anything this side? So that means we shade everything going to the right. And you draw your arrow. That's it. Let's do another one. Yes. Let's do another one. Here we go. Example 2. T less than 5, open parentheses, -1 plus 3, close parentheses. So can we simplify this side? Yes. We start with a parentheses. What is -1 plus 3? 2. Bring down the 5. And what is 5 times 2? 10. Do we know how to graph this? Yes. At that point, get your graph. Because that's what the parentheses indicates. Right. So here we go. 0. And I'm going to start at 10. Here's a 10. So let's see. Look at the symbol. Does it have a little bar underneath? No. So we're only going to mark the spot with an open circle. There it is. And this reads, T is T is less than 10. What numbers are less than 10? 9, 8, 7, 6. So everything to the left. You shade and arrow. Okay, I know. So that's the only thing you're going to be doing for tonight. So make sure you go to page, what's the homework? 139, numbers 1 through 33, odd. Have a good one, everyone. Enjoy your homework. See you guys tomorrow. It's been funny.